So in this setup, we added all these routers, and end user, it ultimately cannot ping 140.100.100.2. I mean, it just can't, because it does not know that this router does not know how to reach 140.100.100.2. Thus, therefore, any traffic that hits the router doesn't know what to do with the traffic. The last stop that this end user can ping is actually just 110.100.100.1. That's the last sort of stop here. It can go through the network, it can do all this, it can do this. It stops here, but anything here in this space, this end user cannot ping. And so then the question again comes, how do we solve this problem? And the answer is OSPF, or routing protocols. RP, not RIP. So so now we're going to go ahead and start implementing routing protocols, enabling OSPF on each router, starting here. Configure terminal. Okay, so now we want to enable OSPF, router OSPF1, and with router OSPF1, what I want to do is I want to add the networks connected to it. So we have 110.100.100.0 wildcard of /24, all in area 0. Again, we're just going to throw everything in area 0 for now as the backbone area. And then now, not only do I want to add 110, the 110 network, I also want to add this 10 network, which is quite strange, but let's see. Let me just show you. Again, these network statements. Incorporate this network into this statement. Okay, so here, so now 110, 110, 110, 0, 0, 0, 0. Nice. Okay, cool. Let's also give it a router ID. Okay, so this identifies the router, so that when we look up, do a IP OSPF database or neighbor, we can see, which router is doing what. Just for the sake of organization, let's do 1. Okay. And then let's see. It says clear. You don't really need to do this right now. And then the other commands that we can check is show IP. We're not really learning anything right now. We don't have any neighbors, so it doesn't really matter. There's nothing going on. See, there's nothing. Well, I guess it has itself. Let's go ahead and move on to the second router. This is where things will start picking up. Router OSPF1. Again, it doesn't matter what the process ID is, network. And again, sorry if I'm beating a dead horse, but just so that we can get this, get a good understanding of this, we're gonna take this network and this network for router 2. Okay. These network statements can start becoming handy when we also, create networks here. And let's say we have another network. Right? Network. So yeah, and then we can start throwing them out here and advertise routes to getting into infrastructure in here. Because let's say we have a server here. How do we get to the server? Well, you can go through router 2 via OSPF and learn that way. But again, that's for another day, another video. So router OSPF1, we're in router 2. We need to hook up 110, 100, 100.0, 0, 0, 0, 0, there, area 0, network 120, 100, 100.0. So far looks good, I think. Okay. Yeah, the neighbor's building. Oh, whoops, area 0. Router ID 2.2.2 and clear IP OSPF process. Yes. Okay, there we go. Here are the neighbors being built. Show IP OSPF neighbor. So router 2, it sees .1 as a neighbor, right? Right here. IP OSPF database. Oops. Oh, you know what? Let's see something here. Show run. I just wanted to check something real quick. Router ID, clear IP OSPF process. Yes. It's ping 110.100.100.2. Okay, now let's ping 120.100.100.1. Let's learn that. Okay, show IP. There we go. Load the neighbors. Come on. Yeah, so neighbor 1.1.1.1 is here. Router ID 2.2.2. here. And then again, these commands, these 3 commands you will always need. Whether you work as a network engineer, as a NOC engineer, as an IT engineer, or whatever. These are always good to know. Show IP route. Okay, so I see the endpoint 0102.01.02. And then show IP OSPF neighbor. Yeah, it sees its neighbor 1. So show IP OSPF neighbor. Hey, who's my neighbor? Hey, 1.1.1.1 is your neighbor, and he is coming from gig 01, right? Gig 01, and right here with an IP address of 110.100.100.1, and that's my neighbor, 1.1.1. So that if you look at router 1, and then show OSPF neighbor, who's my neighbor? Says router 1, your neighbor is here. 2, 2, 2, 2. Cool. Okay, so now ping. So coming from this router, right? What I'm gonna do is do a series of ping tests. I'm gonna ping here. Obviously, that's gonna work. I'm gonna ping here. That should work via OSPF. Actually, I think Direct Connect will allow it, but .2 would be the issue. And then from the end user, I'm gonna try to ping all these networks leading up to .3. So let's ping 110.100.100.2. Yeah, so I can ping .2. The real test is, hey, can I ping 120.100.100.1? 120.100.100.1. Come on. And I can, right? .2. Can I ping .2? How do I get to .2? At the moment, I can't. Let's see if I can turn up OSPF on router 3. Let's see if that will solve our issues. Conft router OSPF 1, network 120.100.100.0, area 0, network. So router 120 here, and then 130 network 130. 100, 100. I hate when that happens. 100, 100, 0. Area 0. So we're going to advertise here and here, and then give it a router ID of 3A3. Yes, I will do that. Clear IP OSPF process. Yes. Okay. So let's go back now. Well, router 3, let's see if router 2 picked it up. Yeah, it picked up its neighbor. Again, let's check its neighbor. Hello, 1.1.1. 1, 1, 1, 3, 3, 3, 3. So, router 2, it sees these two neighbors. Cool. Okay. Real test comes here. Let's go ahead and start pinging stuff. Let's ping that too. Yeah, you know, before it couldn't, and now it can, right? Let's see if we can ping 130, 100, 100.1. 130, 130, 100, 100.1. Gonna say yes that it can, and then yep, now because router 4 is not configured to OSPF, we can't ping anything past router 3. We can't ping anything beyond this point yet, right? We can ping all this via OSPF. So let's see. Ping 130, 100, 100.2 here. Come on, come on, come on. It's gonna fail. Where'd it go? Yeah, fail. It's gonna fail, and then 140 obviously is going to fail to 100, 100.1. It's going to fail. And the minute we turn on OSPF router 4 here, advertising that 140 network, it will work. End user can finally reach the server IP. So let's go ahead and get this finished up. So configure terminal, router OSPF 1 again, network 140, 100, or 100.0 / very easy, all in area 0. Let's also advertise 100, 100, 100. Area 0, perfect, perfectamento. Let's give it a router ID of 4.4.4.4, and then clear IP OSPF process. Whoops, yes, and then show. I should have only one neighbor, right? 3, so 4 has a neighbor of 3, 3 has a neighbor of 4, and 2, and so on and so forth. 1 has 2. Show IP OSPF database. Let's see, router 4.4. Yep, okay. It's learning all these routes here. Okay, so then our final test here, now that we have OSPF enabled in and on router 4, is ping 140, 100.1. 100.1, and it works, right? Let's see if we can ping 140, our final destination of the server. So going from here all the way here, and do we get a fat? Yeah, so looks good. It's learning the route, so you get a few drops, but now it's good because it learned it, and it looks like we're all set here. Via OSPF, this end user can hop these routers and finally get to its destination, right? It forms via OSPF neighbors, and each neighbor is daisy chain advertising its peer routes. And so, long story short, this is how you would get OSPF involved in the routing process. The next video that I'm going to create is I'm going to go deeper into OSPF using GNS3 because again we have limitations with Packet Tracer, and then I want to build the same infrastructure using EIGRP, right? So let's see. I'm going to create EIGRP, BGP lessons, and then again, each video I'm going to go deeper and deeper and scale out. Eventually, I'm going to create another video with more switches and more routers and more servers. But yeah, go ahead and subscribe, and thanks for watching.